So today we're going to build an AI agent from scratch using Langchain, NEXT.JS 15 and DeepSeek. So why do you want to build this bot at all? So we are going to build this bot on top of a website which I had created last year for my brother, Dr. Sid Warrior. This is a neuroscience course called Neuro Mastery. The AI agent bot that we are building on top of this website is to help the users ask questions like when is the next cohort, or how can I do the booking, or can I book a slot for the sales call. So the website would basically have all the details, but the bot would just make it easier to get this content. So we are going to be building 5 types of bots to give you a comprehensive idea about building all types of AI bots. The first one is a simple AI chatbot with a prompt. The prompt hits the LLM and gets the response back. So the prompt already contains information about the neuroscience course. The second is just for your technical learning, where you can basically say that I don't want a textual response back, but I want a structured JSON or a table format back. The third is where it gets interesting. This is an AI agent, which means that I'm not just asking for information back, I'm also asking for it to do certain tasks. I'm asking the chatbot to book a sales call with the sales team, or for the chatbot to find similar courses with lesser price or higher price, or for example, I want to do the booking, make the payment, different kind of tasks which I can create with an AI agent. The fourth is where I do a retrieval. So you might have heard of retrieval augmented generation, or RAG. Retrieval of the course document is basically teaching the AI chatbot more knowledge. So we are basically, the LLM is learning more about this neuroscience course, and we do this using something called text embeddings or vectors, and we store these vectors in a vector store. I will be going more into details into this topic. And finally, the fifth one is where we combine third and fourth together to make it a retrieval plus AI agent, a full comprehensive AI chatbot. So in order to build this, we are going to be using Next.js 15. That is the Vercel's framework that is built, quite popular, which is built on top of React. We will also be using Vercel's AI SDK, which makes it very easy to build good looking AI chat user interfaces, and also AI agents, of course. It goes hand in hand with Langchain. Langchain is an open source library which can be used for chaining LLM calls together, with a lot of great templates and prompt templates available. And a great subset of Langchain is its LangGraph library, which helps you build AI agents very quickly. We will also be using the library or the portal called GROQ, which gives you access to free LLMs which are open source, which are deployed on their system. The 2 LLMs which we are using are Mixtral and DeepSeek. Mixtral is for the basic chat which we are experimenting with, and DeepSeek is for more of the reasoning and more complex scenarios. I have put all of my code on a public GitHub repo. The public GitHub repo is available, the link in the description below, and this is what we will also be demoing in today's session. So before you get started, you need to get access for 3 systems, or you need to get 3 API keys. The first is the GROQ portal, where you can basically access the LLMs for free using this portal. You can also use HuggingFace. So I have, to give an example, I have used a text embedding LLM from HuggingFace. And I've also used Supabase, where I have used it to store vector embeddings for free. And these are the vector embeddings which the AI bot will then use as RAG. Once the API keys are ready, I will clone my project from my public GitHub repo, and I will add my API keys in my .env file. And optionally, I can edit it further to make it specific to my use case. Currently, these files have the neuroscience website content, but the first file you would need to edit is the prompt.ts, which is what the application is sending to the LLM. I will also have to edit the file.ts, which is the document stored in the vector store. The app page.tsx is the UI, which is a standard Next.js 15 concept. The app API chat is the folder where all the backend flow is available. Here you can update the root.ts for each of the 5 chatbots to update the backend API flow. or the app API tools.ts, which is basically where all the AI agents are available. You can add AI agents or update the existing tools which are available. So this is the neuroscience website called Neuromastery Bootcamp, for which I am building an AI agent bot. This is the console.groq.com GROQ portal, where you can basically create an API key to access multiple LLMs. So you can see that there is Llama models and DeepSeek models and Mixtral and a lot of models that you can access. There is a limited version, but it's quite useful to get started and test for free. So you can easily create a new API key by clicking on Create API Key, and this would generate a code which you can add in your local file. Similarly, you can go to HuggingFace, where you can go on the user profile, click on access tokens, and then create a new token for you. This is also a token that you can add in your .env file locally. And finally, this is Supabase. Supabase is an online database where you can create a Postgres database and you create a PG vector concept. Basically, you can add a table called documents, and this is the vector embeddings of the entire content about neuroscience workshop. The Neuromastery Bootcamp that I have has been converted into embeddings, vector embeddings, and saved here. Now let's see a demo of how the application actually looks like. So I would ask a simple question like, hi, what modules are available in the course? Perfect. Yeah, so it has already figured out that these are the modules that are available, and the modules are designed to help you master your thoughts, emotions, achieve a flow state, which is the exact content that I had provided about the website, right? So if I also show you how this works in the API call, if I say, are there recordings available, right? So you can see that there is a call that's going called chat. And this chat is basically making an API call to where the user is asking the question. Let me open this. User is asking the question, hi, what modules are available in the course, which is role user, which is me. The assistant or the chatbot itself is responding with hello. The Neuromastery Bootcamp by this, and finally the user content is, are there recordings available? So the latest question that I've asked is recordings available. The previous two was the chat history, which is also cascaded and sent. Finally, the preview that comes in is the exact response that yes, recordings of the live sessions are available. Now if I further ask a question like, what about certificate? Right, so now this would again generate a new request, but it would have all the 4 of the previous conversations added with the new question, which is what about certificate, right? And this would give the latest one, yes, a certificate signed by Dr. Sid Warrior is provided. So let's understand how this is working in the code. So I go into the application folder, the app folder, where I see the API, and in the API I see a chat and a root.ts. So this is the /API/chat, which you can see here in the network. So if I ask, what about certificates, then there is a API call that's being sent. And if you see here, it is /API/chat, which is basically coming from /chat, and Next.js automatically tracks the /chat API with a root.ts. So if you have a root.ts, it will catch that URL. So this root.ts is responding to the /API/chat post call. So you can see that there is a function called post. Now inside this function, you'll see that there is a model which is being created. This model is basically connected to the Mixtral model, and this is using the API key of process environment GROQ API key. So in our env.file, you will see that there is a GROQ API key. You will have to enter the 4 values over here. And this is the file that it would pick to make the call to the LLM. Let me open that back. Yeah, so here you can see that the model has been created, and this model is basically being sent to the chain of LLM calls that we're doing. In this case, it's a single one, but we are also passing the chat history, which is a complete collection of all the previous messages back to back. So the LLM now gets to see that this is not the first question, but it has already asked 4 or 5 or how many ever questions in the past. And then the final response that comes in is the stream that is put back on the UI. Right? So that's why this first bot will work. The question is, when I simply ask a question like, hi, what modules are available? How does the LLM know about all of these details? So the LLM knows this because we are passing something called as a prompt, and there is a function that I am passing called get default prompt chat, which is basically passing this prompt, right? So it says that, let me put this, yeah. So it says you are a helpful assistant for Neuromastery Bootcamp. Answer the questions about the course using the details below. If unsure, say I do not know. And I've provided the entire course details and the modules and the structure of the course and the FAQs, instructor, everything. Currently, I have not parsed the website and then automatically generated the content. I have added it inside the prompt itself, because in the other chatbot versions, you'll see how there are better ways to do it. Because this is not an ideal way, because the prompt is very large, but it does work because it's able to give the exact response that I need. Now let's move on to the second type of chatbot, which is structured output. So like I mentioned before, it's not really useful from a functional use case perspective, but a structured output can really help when you're chaining applications and you need to retrieve just one part of the response. So let me try the same example that I did last time. So what about the certificates? And if you notice on the UI, it now does not just give the response. It is also saying that the tone was neutral, the entity word is certificate, the word count is 11, and so on. And the call that was made, let me try it again, and recordings, right? So now there is a call that's made to /structured output, API /chat /structured output. The API call that was made has all the responses, but the response itself that comes back is not just the text, it is itself in a JSON format. Coming to the code for the structured output, there is a template variable which basically gets the template for this type of chatbot, which is fairly similar to the first bot as well. And again, there is a model for Mixtral which has been created. You can use any of the models from GROQ here. But what's interesting is under this model, we are using something called .with structured output instead of just fetching it as it is or doing a model.invoke in the previous time. So if you do .with structured output, you will get it in a JSON format, which is what we end up showing on the UI. And finally, we come to the third type of chatbot, which is AI agent. So this is how the AI agent bot would look like, where we can ask it to do certain tasks like finding the next discovery call date or booking a discovery call or making a payment and so on. So the idea of the React agent is mentioned here. I'll also provide the link to this research paper, but this is a research paper that has been used by LangGraph, which is a subsection of Langchain. And in this LangGraph, you can see how there is a React agent template that is created, which allows the chatbot to call tools. And these are tools that we can define or use community tools that we can use in our chatbot. So let's see a demo of an AI agent in action. So if I go to our chatbot and ask a question, when is the next discovery call available? I'll open the network so that you can see the call as well, and I click on send. Because I have clicked on show intermediate steps, you can see that it is making a step in between called get discovery call. Now this get discovery call is something that I have defined. It's not there out of the box, but because of this get discovery call, it is passing a call to one of my tools. The tool is responding with the text. The next available slot for a discovery call is on Monday, Feb 24, 2025. And this response is read back by the LLM to generate the final response. And you can also see it here that when the call called agents is sent, the call is basically making an API call for when is the next discovery call available, and the response is also being given by the tool and not just by assistant. So now there's a third player, user, assistant, and a tool. The tool is helping with certain information which the assistant can't find on its own. Now let's find out what this means in the code. So if I go into the agents folder and see root.ts, I can see that there is an agent. Yeah, so I can see that there is a chat model, chat GROQ, just like the previous examples, but I don't directly make the API call on this chat variable. I am encapsulating this chat under a function called create react agent. This create react agent is a function that is provided by LangGraph. Right, so it's a pre-built LangGraph agent to provide a React agent, and this chat will basically be given an access to this variable called tools, and tools is basically an array of different types of tools which the chatbot could then call. So one of the tools that I have defined here let me just show you this. So I have this file called tools.ts, and inside this tools.ts I have multiple different types of tools. One of them is something called get discovery call details. So I have multiple options that I had experimented with in my test. So for example, a real life scenario here would be that I would connect it to Google Calendar API, and I could actually find out when is the next available sales discovery call slot. Right, so that would be the real scenario, but the tool would then do it, which the standard LLM can't do. The other option is I do a hard-coded response of, say, for example, Thursday, Feb 27th. In this case, what I'm doing is I'm just dynamically setting it to the next Monday, just for the sake of the demo. So whenever you run it, you'll be able to see it to the next Monday. But ideally, in a real scenario, you will be setting it to the Google Calendar API. And because this tool is available in this get discovery call details, which I pass it in my tools array, that is why in the UI, when I make this when is the next discovery call available question that I pass, the LLM is deciding that it cannot take a decision on its own, but there is a tool which can help here. So it is passing this question as it is to the tool. The tool is responding with the response, and the LLM then formats it if it needs and then responds it back to us. Now, what if we wanted the user to find similar courses to the Neuromastery Bootcamp? Now, probably the LLM called Mixtral might not be able to solve this in detail, but we would want something like DeepSeek, which has the reasoning ability to think and logically decide which API to call and then fetch the list of similar neuroscience courses. So what we do here is we provide a tool called Get Similar Courses tool. This would then make an API call again via chat GROQ. We are still using GROQ as the website where the LLMs are hosted. But instead of using Mixtral, we will use a DeepSeek R1 LLM model. And this DeepSeek model is what we invoke to find out a similar neuroscience course in a short response. And this is the description of this entire tool is called to get similar courses. So when I ask the chatbot to get me similar courses, it will check that is there a tool which can get me similar courses and make a call to that. So let's try asking a question like find similar courses, and this would then trigger an agentic call to the backend. I have also put a few console.logs just to track that is it actually getting the calls. I can see that the 3 steps that I've added are working. Now what is interesting is it can see that I am making a get similar courses tool step, and this is responded by DeepSeek. And one interesting thing in DeepSeek is that you will find that there is a section called think, which is the first part of how the DeepSeek LLM does a reasoning. It thinks that, okay, this is the question that asked, where do I start? It's thinking with itself. It's almost talking to itself. And after the entire response is when you can finally see the actual response that it generates. And that is what the Mixtral LLM will take back and then respond back to us. So it's almost like a conversation between Mixtral and DeepSeek, where DeepSeek is also thinking by itself. So there's a lot to explore here with the AI agent, especially when it comes to experimenting with DeepSeek within the tool of an AI agent. Now coming to the 4th type of AI bot, retrieval. Here you can click on upload document and you can provide any document information that you want about your website or anything that you want the LLM to know. You're basically training the LLM in a way. So this content that you see here is basically coming from a file called data and neuromastery course details.ts. So this is a file that you can edit with your specific course content or your structured content that you want to teach the LLM. This content is as it is uploaded into a database, and this is where Supabase comes in. So what we do is we cut this document into smaller embeddings, which is something that the LLM can understand. These are numbers, large numbers, which LLM understands. So when you ask a question, LLM will first look into these embeddings, see if there is a relevant information in here which might be useful for the user, and then fetch this content back and utilize this data for the response. So after you have clicked on upload document and clicked on upload, you can basically ask a question like, what are the outcomes of the course? Let me open the network tab before I click on enter. So this would now make a call to the Supabase as well and fetch relevant data. So you can see here that it is searching for the source, which is the vector embedding database table, the PG vector embedding table. It's finding that line 31 to 36, line 9 to 10, 18 to 19. These are all relevant content which might be useful based on the question that I've asked. So based on all this, the Mixtral, the LLM that was receiving this response, will basically fetch the whole response and do the improved attention, participation in live sessions. These are all the outcomes. So what would you benefit if you attend this course? Right? So it creates a combined response based on all the text here. So the responses here might not be best. So there are a lot of approaches which RAG recommends, which I'll probably cover in a different video. If you're interested, please do put it in the chat. And finally, chatbot number 5, which is called retrieval agents, is a mix of 3 and 4 agents and retrieval. It can basically make calls to agents like the examples that I showed you a while back, but it can also do retrieval, which means it can do retrieval augmented generation or RAG, where it can fetch the embeddings from Supabase. So it's a complete comprehensive solution to access all the content on the Neuromastery Bootcamp website. Unlike the other videos that I've put in my channel so far, this video was much more hands-on and experimental. So do let me know in the comments if this is the kind of content that you're looking for.